Welcome back to IT 3000. Today we're stepping into one of the most important ideas in all of computing. A computer on its own is really just a tool, but the moment you connect it to others, something remarkable happens. It stops being a device and becomes part of an infrastructure. That's what a network truly is, independent machines, made to act as one. So let's put a definition around that idea. A computer network is two or more independent devices linked by some transmission medium, exchanging data according to shared rules we call protocols. And that last part is the key, because a network isn't really the cable, it's the agreement. Without shared protocols, a wire between two machines carries nothing but noise. So if a network is really an agreement, what does that agreement actually need to exist? 4 ingredients. Nodes, the participants, from your laptop and servers to the switches and routers moving traffic between them. Links, the physical medium the signal travels over, whether that's copper, fiber, or radio waves through the air. Protocols, the shared rules we just talked about, and addresses, the identities that let one node find another, from MAC on the local segment to IP across networks, to ports that pick out a specific service. Take any one of these away, and what you have left isn't a network, it's just equipment sitting in a room. Now, those ingredients don't just sit side by side, they're organized into layers, and the TCP/IP model is how we draw that structure. At the bottom, the physical layer is the actual signal on the wire or in the air. The link layer moves frames between neighbors using MAC addresses, internet handles addressing and routing with IP. Transport using TCP or UDP adds ports and reliability, and at the top, application, HTTP, DNS, SMTP, SSH, is where your software lives. Data gets wrapped on the way down and unwrapped on the way up, and each layer only ever talks to its counterpart on the far side. The practical payoff: when something breaks, identify the failing layer first. It tells you which tool to reach for. Let's watch those layers cooperate in a moment you've lived through thousands of times: opening a website. First, DNS quietly turns the name you typed into an IP address the network actually knows how to reach. Then TCP runs its three-way handshake to establish a reliable channel, and TLS layers encryption on top, so from that point forward the traffic in transit is unreadable to anyone in between. Your HTTP request then travels hop by hop, each router picking the next best path, and the response comes back in packets that get reassembled in order before the browser finally paints the page. 5 separate conversations, and they all finish in the blink of an eye. Now, once you understand that a network is really an agreement between machines, the next question becomes, how far does that agreement stretch? That's what LAN, MAN, and WAN describe. A LAN lives inside a single site, your office or your home, where you own every cable and switch, so latency is tiny and bandwidth is essentially free. A MAN spans a city or campus, usually over fiber leased to link an organization's buildings. And a WAN reaches across countries or the whole planet, where you no longer own the wires, you rent transport from carriers. The internet, of course, is the largest WAN of them all. So where do we go from here? Everything we've discussed today rests on smaller pieces, and each of those deserves its own episode. IP addresses and protocols define the agreement itself. Routers, switches, and firewalls carry it out in hardware, and DNS gives it a human face. We'll take them one at a time, starting in the next concept with the thing all of this exists to move: data. Let's leave you with 3 anchors. First, a network needs all 4 ingredients: nodes, links, protocols, and addresses. Take any one away and the whole thing collapses. Second, TCP/IP works by wrapping data on the way down and unwrapping it on the way up, which means when something breaks, you troubleshoot one layer at a time. And third, reach decides ownership. You own your LAN, you rent your WAN, and that single fact shapes cost, design, and control. Keep coming back to the core idea. A computer network is just independent machines made to act as one. I'll see you in the next episode.